Most people study for the GMAT the wrong way. They treat it like a school math or English test and spend weeks grinding through content. But here's the thing, the GMAT doesn't reward knowledge, it rewards strategy. It's not about solving everything, it's about solving smart, fast, and under pressure. And that's why I develop a method. Something I teach in my full GMAT Live online course that helps you do exactly that. In this lesson, I'm going to show you the first piece of that method and how it instantly makes many questions easier and faster to solve. Hi, my name is Andrea Madeira and I'm the founder of Entry Prep, your all-in-one solution for preparing MBA or master applications to top business schools. The GMAT is used by these top business schools to test how you think, how you handle pressure, data, and logic time under constraints. You don't need advanced math. You don't need perfect grammar. In fact, the GMAT uses very basic concepts you learned in school, but it wraps them in tricky logic and clever traps. What you really need is a way to deal with those problems efficiently, to save time, avoid mistakes, and stay in control during the exam. That's why I created this method, a set of 4 essential strategies that give you control over time, process, and accuracy. In this video, I'll share the first one with you. The others, well, they'll be revealed in the next videos and they are just as powerful. To have access to them, you just need to join our WhatsApp group and the link. So this first strategy is represented by letter B, and B stands for backsolve. Backsolving flips the process. So instead of solving equations and hoping to find the right answer, you test the choices directly in the problem to see which one works. And this is especially perfect when the question has variables and the answers are numbers, or you're solving for a specific value, or even if the algebra looks long or annoying. Let's look at 4 different examples where you can see how backsolving works in practice. So in my first example here, let's read the text. A coffee machine manufacturer plans to increase the price of one of its models by $200. At this new price, the company expects to sell 5 fewer machines per week, but its weekly revenue will increase by $4,250, reaching a total of $105,000. How many machines will be sold per week at this new price? So first of all, let's write the equations that we need to solve this exercise. So revenue is price times the number of machines sold. Let's call P the old price. Calculate the revenue. This is going to be P times the number of machines. Let's call it M. At the new price, that is P plus 200, we are going to sell 5 fewer machines. So M minus 5 would be the product of these two numbers, the revenue, reaching $105,000. And for the old price, the revenue is $4,250 less. This is going to be $100,750. So if you want to solve these equations to find the value of m minus 5, you are going to obtain a second degree equation. It's completely out of question to solve a second degree equation here. And the reason is you have the result in front of you on the answer choices. Why not to use the values of the answer choices, plug in the equations, and see which one works? That's what we call backsolving. So when you are going to choose which answer choices to test first, usually you start by answer choice C unless one of the others calls your attention. So at this case, I think there's not an obvious answer choice. So let's start with C. You may be wondering why C. Usually the answer choices on the GMAT are in ascending or descending order. That means that if you start with answer choice C, you are going to test the value in the middle. And probably, if C doesn't work, you are going to have clues if you need to test lower values or higher values, limiting the number of tests you need to do or the number of answer choices you are going to test. So here at this case, let's start by C. Remember that the answer choices are the number of machines at the new price. So this is going to be m minus 5. This is what the question is asking us. So let's substitute m minus 5 by 55 and m by 60. So the price would be 100,750 divided by 60. Let's divide by 10 on both sides of the fractions So this is going to be 10,075 divided by 6. So this value is not divisible by 6. Let's leave it right there this way. And at the new price, we are going to have 105,000 divided by 55 minus 200. So here, let's divide by 5. This is going to give us 21,000 divided by 11 minus 200. So those values are not the same, so it's not answer choice C. So now let's test answer choice D. So at the old price, we are going to have 100,750 divided by 65. Now let's divide by 5. So this is 5 times 13. So cross 5. And then if we divide 10,075 by 13, this is going to give us 775 times 2, 1,550. Now at the new price, we are going to have 105,000 divided by 60. Let's divide already by 10 and then minus 200. So this number is now divisible by 6. This is going to give us 1,750 minus 200, and this is exactly the same value as in this equation. So our answer choice is answer choice D. Now let me show you a second example, different from the first one. The first one was a word problem, but here we have a completely algebraic exercise. However, we can also use back solving here. So we know that a is different from 0 and a is equal to the square root of 6ab minus 9b squared, and we want to know the value of a in terms of b. Of course, you can use algebra here, especially if you feel very comfortable with algebra. It's not a super easy exercise, but you can use it. So you need to square both sides of the equation, and then you are going to find a common algebraic expression that you need to solve. However, if we use back solving here, it's much easier, and especially when you are a person that is not so comfortable with this kind of algebra. So here, I think we should start with answer choice C because it's b squared. It's not the easier of our answer choices. D, same thing, and E, you have a negative sign. So the easier ones to test are going to be A and B. So let's substitute A first by B. So let's test answer choice B first. So B would be equal to the square root of 6b squared minus 9b squared. So this is not our answer choice because this is going to give us a negative sign here inside the root. So second one is going to be A. So let's test 3b, substituting a on the equation by 3b. So 3b is equal to the square root of 6 times 3b times b minus 9b squared. So here we have the square root of 18b squared minus 9b squared. So this is the square root of 9b squared. That means 3b. So our answer choice is going to be A. So now let me show you a completely different exercise that involves coordinate geometry. So our exercise says that the circle C is defined by the equation x squared plus y squared is equal to 25, and line L is defined by the equation 4y is equal to minus 3x plus 25, and is tangent to the circle at exactly one point. So what is the point of tangency? So a point of tangency is the point where the two, the line and the circle, cross each other. Once again, don't use algebra here. It's much more complicated than just testing the answer choices here, plugging the values of x and y on the equations and seeing if the both equations are true for those values x and y. So let's start by this one. So you have x squared plus y squared is equal to 25. Let's use this one already to eliminate a few answer choices. So remember that the first value is going to be x and the second value is going to be y. So if you substitute here 1 squared plus y squared, this is not going to give us 25. The same reasoning for E, so those ones are gone. And C, same thing, you are going to have 4 squared plus 4 squared is going to be 16 plus 16. This is not 25, so this one is already crossed too. Now 3 and 4, 4 and 3, 4 squared or 3 squared. Let's test B first. 3 squared plus 4 squared is going to be 25, so I'm testing B. Now let's go to the second equation, substitute y by 4 and x by 3 and see if it gives you 25 also. If it's not this one, is D, and you don't need to test this anymore. So 4 squared is equal to minus 3 squared plus 25. So this is true. 16 is equal to 16. So our answer choice is B. Now I want to show you a last example. An example that doesn't come from the quant section, but from data insights section. And I have this question here just to show you that you can use back solving even in this section. And this is a two-part analysis. Let's read the exercise first. So a train is moving along a straight track and its speed is increasing at a constant rate. At time t is equal to 0 seconds, the speed of the train is v0 meters per second. After 8 seconds, the front of the train has traveled exactly 144 meters and its speed at that moment is v8 meters per second. In the table below, select the values of v0 and v8 that are together consistent with the information above. So what we know is the time spent here is 8 seconds to do a distance of 144 meters. So with these two values, you can calculate the average speed during this distance. So the average speed would be 144, so the distance divided by the time. So 144 divided by 8, this is going to be 18 meters per second. So now, how can we find the value of V0 and V8? We have the average rate. You know that V0 is less than V8 because the rate is increasing over time. Now, you need to select two numbers, one for V0 and the other for V8, whose average is going to give 18. So, and since V0 is less than V8, there's no much options to test. So you can use 6 and 12, no, because this is not going to give us 18. 6 and 18, same thing. 6 and 21, let's test this one. 6 plus 21, this is divided by 2. This is 27 divided by 2. This is not 18. And we need to increase more the value. So 6 and 24. 6 and 24 divided by 2 is 15. We need to increase more. Let's test 12 and 24. Well, 12 plus 24 divided by 2, this is 36 divided by 2, so the answer is 18. So these are the options we are going to choose. So V0 is 12 and V8 is 24. For this particular problem, there would not be another way to solve the exercise unless you use back solving. And this happens many times during this kind of exercises, the two-part analysis on data insights. This was fast, right? This isn't about shortcuts, it's about using the right tool at the right time, and that's exactly what GMAT top scorers do. This was just the first move in a strategy I call the BEST method, a framework designed to help you solve faster, manage your time better, and avoid the traps that cost other students points. Do you want to discover what the letters E, S, and T stand for? Those strategies are going to change the way you see the GMAT. They're absolute game changers, and once you learn them, you'll never approach the test the same way again. So click the link and join our WhatsApp group. That's where I will send you the next videos packed with powerful strategies to help you study smarter and, of course, score higher. In our group, you'll also have access to free GMAT webinars, real examples with step-by-step solutions, and of course, exclusive content from our complete GMAT Live online course. If you're ready to stop wasting time and start preparing the right way for the GMAT, this is definitely your next step.